Hello everyone, my name is Tracy Dice and this is my course presentation using Microsoft Excel. The agenda for this presentation, I will introduce the project, give a brief demonstration, look at some practical applications, and then have a slide for questions. As an introduction, we know that trends show students are amassing more student loan debt every year. So how can we help students with this debt? The answer is this Excel project. We will be creating an amortization schedule. This project can be used in any financial literacy course. Specifically at Dakota Wesleyan University where I work, it's called Business 141, and it is a breadth of knowledge or general education course. We will now move on to the demonstration. So I'm going to share my Excel file with you. This project starts with a set of givens. You can customize this any way you want. I start with $40,000, an APR rate of 5.5, loan years of the typical 10 years for a student loan, and then a frequency of paying every month. The reason we use a generalized set of givens is so that students could potentially make mistakes in their schedule, and if you all have the same numbers to start with, students can make sure they fill it out correctly, and then later on they can customize this Excel spreadsheet to fit their own personal situation. So we start with calculating a payment amount. So how much are you going to pay per month if you take out this situation? And Microsoft has extreme power here when you show students these functions. So we hit the function button and then you search for the payment function or the PMT function. Under financial is where it would be if you haven't used it recently. And you insert the function. Here you can talk with your students about how if they're not quite sure what all of these things stand for, Excel gives you a brief explanation down at the bottom. So our rate is the interest rate per period of the loan. So we have an annual interest rate. So they even tell you if you have quarterly, you need to divide by 4. Since we're doing monthly, we need to divide by 12. However, another thing we want to do when we're creating this Excel spreadsheet is make sure that we cell reference everything. As I already mentioned, this situation is not going to apply to every student. So we want to make sure that when students update these givens, it's going to automatically update the rest of the Excel sheet. So for our rate, we are going to take our APR, so our annual rate, and we are going to divide it by the frequency. So we're paying monthly, so we're going to divide it by that D5. Our NPR, down here it tells you it's the total number of payments for the loan. Well, if we're paying monthly for 10 years, we take monthly times 10, and we're going to see that it tells us right there we're paying for 120 months. The present value is just your amount of student loans, and your future value is a 0. The type of loan down here, that deals with whether you pay at the beginning or the end of the month. And typically, I don't get into that much detail with students, so I'm just going to leave that blank. You don't actually have to do it. And when you hit done, you'll see that this is actually a negative number. However, we talk about the fact that in order for the rest of our Excel functions to work, we need to put a negative in so that this number comes out as a payment of $434. To calculate the total interest, we again are going to use a formula, but not from the formula button. We're just going to type in equals, and we are going to calculate how much money you will pay in total by taking the total payment amount per month and multiplying it by the total number of years and the frequency. And once you do that, you'll see that you pay $52,000. So to finish figuring out what the interest is, you simply subtract the student loan amount. And you'll see that you pay $12,000 in interest over the life of this loan. We then go in to build our amortization schedule. And again, we're going to use cell referencing so that if the givens change, everything else updates. So we see that our balance, we're going to equal our current student loan amount of $40,000. We then need to calculate our interest amount. And we do that by, again, using a formula. We're going to take E12, and we are going to multiply that by our rate. And again, it's monthly, so we want to take our rate and divide it by that. A difference here compared to what we did before is that we're going to be using the fact that Excel will let us fill down all this way to the 120 month mark. And we don't want these cells to change. We don't want D3 to become D4. We don't want D5 to become D6. So we have to use what's called absolute referencing. And you do that by simply putting dollar signs in front of the D's and the numbers. Now those cells will never change. So we find we're paying about $183 worth of interest in the first month. And so we're gonna now figure out how much principal we're gonna pay by taking our payment amount and subtracting our interest rate. And again, our payment amount is never gonna change. We're always gonna pay that $434. So we absolute reference that. We don't want to absolute reference the C13 because we want that to change as we go down the months. So we find that we're going to pay about $250 worth of our principal. And then to find our new balance, we take our balance from the previous month and we subtract the principal amount. Once we get those three filled in, we will highlight them and grab the little box and fill it all the way down to 120 months. And see that we end up with a 0. So another thing I do with students is show them the power of paying extra. So what we typically will do is take your payment amount and then divide it by your frequency so that you're paying one extra payment per year. So about an extra $36 is what this one comes out to be. So now we're going to use that NPER instead of the payment and figure out how many months do we have to pay now if we pay extra. So with that, we're again going to do our rate divided by our months. And now we're not going to actually figure out the payment like we did before. Instead, we're just going to say, well, we're going to make this negative because we made our payment negative before. And we're going to pay the original payment plus our extra that we're going to pay. And we need to put that in parentheses so that way it takes the negative of both of them. Again, our present value is 40,000 and our future value we want to be 0. And we find out that we're only going to pay 108 months instead of 120. When we want to figure out our months saved, we simply say equals our 10 times our 12 and subtract the month before, and you don't need that parenthesis in there. So we save 12 full months. To figure out our total years saved, we're going to take J5 divided by 12 because we are paying monthly, and we find that we save 1 full year. To figure out our new interest amount, we are going to have to take our total payments, so equals our D6 plus our extra amount, so the total amount we're paying per month, excuse me, multiply that by our J4, so the total months we're going to pay with this amount, and then we're again going to subtract our 40,000, which means we're now only going to pay $10,000 worth of interest. And to calculate our interest saved, we hit total interest and subtract the new interest. So we save almost $1,200 or almost $1,300. And then we fill out again our amortization schedule. So set that equal to 40. The difference here is that now we have extra principal added in. So our next one is going to say equals our original balance, again, times our cell referenced D3 times our cell reference, or divided by, excuse me, our cell reference D5. That gives me my interest amount. It's the same interest amount at this point. My principal amount is then going to equal D6, again, absolute referenced, minus your interest rate. I accidentally hit the wrong thing, minus the interest rate, sorry about that. And then we're going to always have this extra principal amount there too, after we're done paying that interest. So we are, again, going to cell reference that J3. To find our new balance, we want to take our old balance from the last month and subtract both the principal amount, and the extra principal. And then you again just fill down. And if students fill all the way down to 120, they'll find that around in between month 108 and 109, they go negative. And they'll ask you, what did I do wrong? And you then have a conversation about the fact, well, you paid off your loan in month 108. So now all this extra is money that you could be putting into a savings account somewhere. Again, one of the cool things about creating an amortization schedule is that students can then go and say, okay, how far into paying off my debt am I after a year? How about after 24 months, so 2 years? And they can see around where they'll be. And then once they have this built, students are able to just go back in and customize it. So if they don't have $40,000 worth of student debt, maybe they only have $20,000 worth of student debt. Maybe they've got more than that. They go to a more expensive school and they have, $70,000 worth of student debt. Everything just automatically updates. Maybe their interest rate is only 4%. And it shows them again what they'll be doing every month, but then it really does help students look at this extra principal amount and see how much could they be paying extra? Could they make an extra $100 on this loan? And what difference does it make? If we go back to our original of 40,000 and 5.5%, just because, if you pay an extra 100 instead of an extra 30, you save 2.5 years and almost $3,000 worth of loans or worth of interest. And again, if you make this a higher interest amount or loan amount and interest, and if your interest rate goes down a little bit, you still can save over $2,000 on your interest. Oops, and I want to make that be my payment divided by 12 there. So if you make an extra payment every year, you save about $1,500. But again, if you make that $100, you save almost $2,300 again. What if you pay an extra $200? And it just shows the students how much interest they save. Another cool thing to use about this with is you get to see a scatter plot over time of how your student loan is decreasing and about where you will end up paying it all off. As you can see, I also have a mortgage template. It's got a few extra things. It's got the house sale price. If you're going to put in a down payment, what percent would you like, your interest rate, and the number of years. One thing that this is very beneficial for is typically you can find, once you've filled this part out and done the student loan template, it's very comparable to filling out the student or the mortgage template. And this is a great one for students to use and see the difference between a 15-year mortgage and a 30-year mortgage. So we're now going to go back to the presentation. All right. So what are the practical applications? Again, students can use it for mortgages to see differences in timeframes, 15-year compared to 30-year, or interest rates, what they want their monthly payments to be, or putting hiring or paying extra. They can do the same thing with a car loan, or they could even tweak it and create a savings account and how much they would earn by investing certain money instead of spending it. With that, I will happily take your questions and look forward to answering them. And here are my references. Thank you so much for watching.